this will be an example of the principle of inclusion-exclusion with three sets. In this case here, I'll just give this setup of a township where we know that 750 of the residents have a smartphone, 620 have a laptop computer, and 480 have a desktop computer. And then we're told how many have two of them and how many have all three of them as well. So let me go ahead and label some of this first of all. So I'm going to take the smartphone here and say that P is the set of residents with a smartphone. P for phone. And then the next one is desktop computer. So because there's two computers, I'll use D for desktop computer. And then L for laptop. So we know how many have. There's 750 with a phone, but some of those will probably also have a laptop or a desktop or both, etc. So in fact, we're told that sort of information here, but what we want is how many residents have at least one of these three items with all this information about how many have two of them and how many of all three of the different things. So what we can do with this first question, number one, is we're asked how many residents have at least one of them. That would be how many things there are in the set P union D union L, and we know that's how many things are in each of the sets individually added, minus how many are in any two of them at a time, plus how many are in all three simultaneously, like so. And we have those numbers above. They are simply 750 plus 620 plus 480 minus, let's see, 420 have both a laptop and a cell phone, laptop and a phone. That would be this one right here. So in the order, I'll put the 420 here. How many have smartphone and desktop? That's this one here, and that's 390. How many have a laptop and a desktop? That's here. Laptop and a desktop, that's here. That's 212. And then how many of all three? Add 164. So it's that sum right there. And that sum right there, I believe I did this right and got 992. Double check me on that, right? 992. Now the next question says, how many have a smartphone or a laptop but not a desktop? Well, there's a number of ways you can do this, but I'm going to just show you one technique that will help you do this. You do not have to do it this way. You can do it without a Venn diagram, but a Venn diagram is helpful. So I'm going to try to squeeze in a Venn diagram here. I don't have much room on this little slide right here. So let me get a little thinner pen and do what I can to squeeze it all in here. So I'm going to draw the three right here and try to make the sectors big enough so I can put numbers in them. And this will be, I'm going to write P here, D for that one, and L for that one. Okay. And so what I'm going to try to do with this right here is in each of the sectors put how many lines just within that sector. I know the whole of P, if I take all of P, like so, just want to indicate that, that's 750. Is that the one? Yeah. But I want to know how many are in each of these little sectors here. So the easiest way to do this is work from inside out. And so inside here I know there's 164. Hope you can read that. Let me try to write that a little better. Ah! Okay, I get the P back and this one back. There we go. So that made it a little bigger so I can write a little better. So 164 goes in there. Now what I know is in each of the intersections of two of them, I know how many those are. So this one right here, for example, this intersection P intersect L has P intersect L has 390. Let's make sure I have that right. Phone and desktop. No, 420 phone and laptop. That's P intersect L. So there's 420 there. And so in the part I haven't marked yet, that doesn't include the overlap of all three, I would need to take 420 minus 164 to get 256. So there are 256 in that region right there. Those have a phone and a laptop, but not a desktop. I guess I've already answered the question. So by this right here, we have 256 is the answer. Now you can similarly fill in the rest of the diagram to answer other questions that I didn't ask here. So for example, if we want to know how many have a phone and a desktop but not a laptop, then phone and desktop, there are 390 of those in this little thing right here, 390. Yeah, that little section. And so 390 over here, I'll do this. Let me do it down below. 390 minus 164. This is phone and desktop. Would also include those that have the laptop as well. Minus phone, desktop, laptop. Those numbers gives me how many have the phone and desktop, but not the laptop. And that difference right there is 226. And then you can find out how many have them singly. This is 104. How the heck did I get the 104? I took the 750 and subtracted the things in those intersections there. The other parts, the other numbers that have phone, but also have one of the others. So those are 104 is the number that have the phone and none of the computers. And down here in this little section, this one's 48, using the same idea. So you should probably go through and try to fill these two in here. Maybe pause it. I'm going to fill them in just a second, but you can pause it, try to fill it in, and then I'll fill it in here. That's a 42, and that's a 152. Yeah, okay. So then we could ask other questions like that, like we did here, and you can answer those in that way. Again, there are different ways to do it, and you don't necessarily have to fill in the whole thing to answer the question that's posed.